Hi there! This is your Chief Marine Edu at your service.
But before we start, thanks for watching. Kindly click the subscribe button, notification bell, and like it if it pleases you. Let's begin.
This is the second segment in the first series of liquefied petroleum gas carrier ship cargo operations. Let's continue from Part 1 LPG cargo operations. As mentioned in Part 1, basing on the P&A manual of this model ship, the vessel is inerting operations can be done in 3 days. To start with, let's talk first about inert gas system. What is it for? In what sequence of cargo operations they are needed in LPG ships? How it is applied and why it is so important to use it and thus became part of operational cycles on board this ship. By definition, an inert gas system primary role is to prevent risk of fire and explosion. A system of preventing any explosion in the cargo tanks of a gas tanker by replacing its atmosphere to a neutral condition where the fire triangle cannot exist. Basically, its main purpose is to remove or lessen one side of the fire triangle. Yes, that is right. For combustion to occur, 3 components must be present: heat, fuel, and oxygen. If any one of these components is missing, combustion cannot occur. Through practical reasoning, first, by nature, the ship itself carries or will carry cargoes of flammable gases, which is basically not an option to remove. Second, heat sources such as accident like lightning strike, electrostatic discharges, and many other factors which may be mitigated but always unpredictable or unforeseen. Sort of just like a thief waiting to strike. Thus, the most obvious side of the triangle is oxygen. Easier to predict and control its level, and by using IGS or through inerting would make it almost negligible or cannot support combustion. So, how is it applied then to LPG operations and why? In cargo operations, such as loading, take note that our scenario is that the ship came from dry dock. Hence, its present tank atmosphere is breathable, filled with air. To prepare a cargo tank for loading, LPG cargoes has to be gassed up, or as we term it, gassing up operation. Try to imagine gassing up a cargo tank filled with air, which is basically composed of nitrogen, carbon dioxide, other gases, and lastly the most obvious component is oxygen. With this condition, we are looking at the possibility of creating the right mixture, and in turn would end up to fire and explosion. Thus, it makes sense to get rid of the oxygen. Inerting has to take place in order to meet the requirements of gassing up. Okay, this is a typical design of an inert gas system for LPG. We need to be familiarized with this system because this is a little bit different with the inert gas system that you'll find on board other tankers like product carriers or crude oil tankers. So just for comparison, we have to understand this so that you'll get to have a better perspective of what's going on. As you can see here, we have an inert gas generator, or we call it IGG. And basically what's happening here is the combustion process. There's an oil mixture like your engine in your car vehicle, and there's an air. It passes through this, and there's a burner. So it ignites, and then of course it creates combustion. That byproduct of combustion is basically an exhaust gas. That is the same thing that comes out from the muffler of your car vehicle, except that it goes through a more thorough process. One of which is that, of course, this is a so-called combined burner and scrubber. As the combustion product comes out, it goes through this chamber of sprayers, and thus, of course, the smoke or the combustion product passes through these scrubbers so that it will be removed with impurities like sulfur, soot, and many other unwanted materials or components of that byproduct of this combustion. And since it passes through a sprayers, it will be wet, so then it passes through a so-called demister. That demister again will further filter the other impurities that you don't want to be included in the IGS byproduct. So once it's done, then it passes a so-called cooler. Take note, we are in an LPG ship. We don't want to put in heat into your tanks. So basically, you have to cool down further that IGS product before you can put it into your tanks. Second thing, also, you don't want that kind of IGS byproduct with wet consisting water because as you can see, it passes through a scrubber, and then of course it was cleansed by sprayers of water. So you have to take out that kind of water or other humidities into that byproduct of combustion. So it passes to a so-called absorption dryer. That absorption dryer may compose of materials like silica gels. Silica gels, you know, it can absorb water and humidity. So once that passes through that system, and the oxygen analyzer also analyze the oxygen already is well below or just within the quality that is required to be injected into your tanks, then of course this system will either open up to go to your non-return valves, or again it pours out to the atmosphere. Such system may also have a design like it will return again back to the same cycle and reprocess. So in this case, it passes through after that through a non-return valves. There are two there, and there might be also a spool in this area and another isolating valve. Now this is a little bit different with the type of inert gas system you'll find on board in crude oil tankers or product carriers. So I'll show you also a comparison so that you will not get confused. So this is of course the inert gas that typically you'll find on board LPG ships. Other than of course the nitrogen generator, especially with ethylene ships and LNG, there is a combination of inert gas system, and at the same time they have also nitrogen generator. With LPG ships that carries the normal liquefied petroleum gases such as propane, butane, ammonia, and of course if this cargo doesn't require nitrogen, which is not actually requires so, then there is no need for nitrogen generators. However, if in any scenarios that it requires, then such nitrogen gases may also be requested from the shore side or terminal. Now, as I have mentioned earlier, I'll give you a bit of a comparison with regards to the IGS system for LPG and to oil tankers. As you can see here, the principles are almost the same. The applications are a little bit different, but the principles in general are almost the same. For example, inert gas system is utilized for purging, inerting, and gas spraying, and that goes the same for LPG. But when it comes to discharging cargo, in oil tankers, they utilize the inert gas system to maintain positive pressure and at the same time so that there won't be any ingress of air in the tanks. So still they are maintaining a very neutral atmosphere that won't support combustion. But with LPG, you cannot do that because inert gas is of course not compatible with the cargo that you are carrying in any LPG. I'll have that in the next discussion of this segment. So as you can see, comparable to LPG, in LPG we have this cooler, regardless of what type. It has a refrigerated dryer and absorption dryer to bring down the humidity or dew point of the inert gas product so that it is cleaner. It doesn't have any water content or low humidity, so that there won't be any water that gets into the tanks. And this is basically related to the cryogenic or cold temperature that we are carrying. It creates hydrate formation. You don't want solids to be created or produced within your tanks. That's the reason why it has to pass through a dryer and a cooler. In the oil tankers, they don't have that. And also, the difference is that
with regards to the deck seal, the deck seal basically is a barrier in between the hazardous area and safe area. So basically, if there's a backflow of vapor going through the engine room, it will stop into this deck seal. On the other hand, in LPG IGS system, it doesn't have a deck seal because deck seal contains water, and again, you have dried already your inert gas system byproduct, and what's the point of putting in a deck water seal in the LPG inert gas system? So instead, they have an equivalent of deck seal, which is a non-return valve. It does the same thing, and of course, it will protect the engine room with a vapor return from the cargo tanks to the engine room. So that's the difference. Also, production of inert gas system in oil tankers mostly are extracted from the boiler uptakes. Sometimes we call this in another term as flue gases.
While in LPG, they have an inert gas generator. So basically, they create their own combustion with this IGG or inert gas or generator. So that's the comparison. Finally, let's discuss the inerting procedures. In inerting, there are two common methods. Number one, displacement, and number two, dilution method. In dilution method, this can be used also depending on your ship design, inert gas system capacity, and related medium of gases or atmosphere inside the tanks. We shall focus on the displacement method, which is the method generally used to change the tank atmosphere. This is because it minimizes the amount of cargo vapor which has to be produced, and hence the time to complete the operation. Also, it minimizes the amount of cargo that has to be vented if related to purging operation, and consequently both the hazard and cost. And lastly, it is more efficient and ensures all the H2O or water and carbon dioxide are removed. Since our scenario is that the vessel came from dry dock, as mentioned earlier, its present atmosphere is gas-free condition or filled with air. And at this point, let's assume it's dry clean except being a gas-free atmosphere. Now, let's study first the comparison of density of gases or medium. This will give us a better view on how we may proceed with the operation. Likewise, basing it in the P&A manuals and operational guidelines of such vessel. Now, this is a brief comparison of density of gas with air, and that is at the same temperature and pressure. Take note that at different temperature and pressure, the densities might change. So, in this example, as you can see, air is 1.0 and the rest of the gases are heavier, while ethylene and ammonia and methane are lighter than air, and even nitrogen and ethane and inert gases. While nitrogen is a little bit lighter than air, ethane is a little bit heavier than air, including inert gases. The rest of the LPG are heavy densities. So this actually will be the one to determine our methods of introducing the medium or vapor or gas into the tanks, whether it's on top or through the bottom. Inert gas, as shown, is heavier than air, and consequently, the medium or substance, IG, must be introduced at the bottom of the tank through either the liquid line or the bottom purge grid if fitted. In this view, we have here our model ship pattern in a simulator. Pipings are shown in a schematic diagram, and you could easily see and trace the lines. Hence, with this method of displacement, we shall introduce the inert gas through the bottom as shown here, and air is removed from the top of the tank through either the upper purge grid or the vapor line. The air atmosphere in whole is then vented from the vent mass or through the vent mass out to the ship, or even using the manifold pipelines and valves, since the vessel is at open sea. Now, let's simulate to give you a better overview of what's going on with inerting. So first, of course, we line up with the inert gas system. This will be done first on hand, so you need to go through the planning Of course, there's a guidelines on board. You'll be able to see this on the procedure and manuals of your vessel and guidelines for cargo operations. So in this kind of schematic diagram or using a simulator, all we need to do is trace the line and line up accordingly. So there are two things that we can do. We can have a series of introduction or cascade, as we call it, for each tank, meaning to say it goes to the bottom of one tank, comes out from the top, and goes to the bottom again of the other tank and comes out the tank, and so out and so forth till it completes and up and goes out to the last tank up to the vent. In this case, we will just do a parallel displacement. So we will be putting in spool pieces, and as you know, in reality, spool pieces are huge, heavy, and of course a minimum of 12 bolts for each side and plus cascades. So it's not easy to connect them. So this is done by the help of the crew. So we're gonna put in, as you can see, one for each line, and we will be introducing through the bottom. So as you can see, we trace the line, we open this valve, and since we need to run the cooler so that it will be dried and that the remaining the humidity or water content is minimized, we will need to pass through the cooler. Assuming the cooler is running and we are ready. So now if you trace the line, it goes through here, spool pieces are connected here so that it can go all through all these lines to the bottom of the tanks. So we open the bottom of the tanks, as you can see, like this, opening now, and of course opening here, right? Now if I run now the inert gas system, the inert gas should pass through the cooler, it goes through this line and then all the way for each tank bottom, 1, 2, 3, 4, and then of course from the bottom of the tanks it replaces the air, pushes it back to the top, up to the top, and then outward from the top of the purge line for each tank, and then it goes out to the vent mass. As I mentioned also, it can be bent out to through the manifold, so we can also connect these spool pieces here. At this point I just opened it already because I mentioned there should be an advanced planning, so I open it already, and we don't need to connect a hose because we are at open sea, so it just goes out on either side of the vessel. So in all actuality, all pipelines and equipments will be purged with inert gas eventually. So we need to do this first through the tank. As you can see, we need to open the valves, and this is where it goes through the bottom as shown in the animation, and then it comes out through the top. Again, it comes out through the top of each of these, and then it bent to the mass, and then of course at the same time it goes through the vent mass, at the same time it goes through the manifold. Eventually, after completing the inert gas by monitoring the levels of the tanks through the sampling point, there is of course a gas measuring device that you'll be able to see how much is the quality or quantity of the volume of oxygen in your tanks. If it meets the requirement, that means to say that you are already have completed the inerting, and then of course after that you follow with the pipeline system. So everything should be open, spool pieces, and then you line up, and then it has to go through every part, even the reliquefaction plant or refrigeration system. All valves and spool pieces should be open and it passes through. Remember, you will be gassing up soon after completing inerting when you arrive to your ports. So when the gas or LPG vapor passes through your system and you still have air, and that's not good. That is actually hazardous and dangerous. That's the reason we need to inert the whole system, and of course primarily first for the tanks and then afterwards all the pipelines. So you go and open all the valves through here, etc., and so on and so forth. I do not need to complete and show you all the valves to be done, but using your common sense and logically, of course, all you need to do is trace the line, line up, reline up, and divert the inert gas
to each of these system. For example, I want to divert it to the compressor room. All I need to do is open these valves and open everything. So there is no pattern actually when you are inerting or purging. All you need to do is open valves. There is no sequence for opening valves. Just open everything. As in, you have to let go all of the air out of that system. So that's the function of the so-called inerting system. So this complete our discussion in inerting, and of course this is just for educational purposes. The real sequence that has to be followed is the one that is written under your ship guidelines in operating procedures. And then of course everything that you have in principles in theory that you have learned will be applied of course in parallel. But you need to check and of course double check it with the system that you have on board. The whole principle are exactly the same, but in terms of the design of equipment, capacity, and how the pipes are laid out, then of course the chief officer through the supervision of the captain has to analyze these kind of things, and of course in cooperation of your gas engineer and the rest of your crew members.